How's it going, folks? You are very welcome to today's lesson on glacial landscapes. Today is going to actually be our last lesson on this topic, okay? So guys, just in front of you there is a quick little recap on some of the stuff we've covered. So top bit there, features of glacial transportation. And a glacier transports its material in what's called a moraine, okay? A moraine, basically an amount of loose material, rocks, sand, sediment being carried in the glacier. And these can be found, there's lateral moraines which are on the side of a glacier, medial moraines in the middle of a glacier, ground moraines at the bottom of a glacier, and terminal moraines at the end of a glacier. Okay, the features of glacial erosion, we have the one we looked at in detail was a cirque. A cirque is an armchair shaped hollow near the top of a mountain where a glacier starts. A cirque is caused by the erosion of the glacier eroding the mountain via the processes of plucking and by abrasion. Okay, we look at that in detail. Now, what separates a cirque? So an arête is like the knife edge between two cirques, a narrow ridge of rock between two cirques there. It'd be kind of like running your hand over the edge of a pyramid, okay? It'd be kind of a sharp, jagged edge that separates two sides. We have a U-shaped valley, which used to be a V-shaped valley, but was carved out by a glacier. What else can be found? What else is a feature of glacial erosion? A fjord. So a fjord is a U-shaped valley that's basically completely full of water. Okay, we then have features of glacial deposition. So we must know one feature of glacial erosion in detail, which is our cirque. We must know a feature of glacial deposition in detail, which is our drumlin. And then we must know a feature of meltwater deposition, which we're going to look at today. Okay, so our feature of glacial deposition we looked at was our drumlin, our oval-shaped hill. Again, guys, remember it's kind of like it's not completely even in shape. So it's got one steep side called a sill, and then the glacier kind of acts as a rolling pin, and the other side is kind of a smooth, kind of a gradual slope. Okay. We're going to look today now at an erratic. So we're just a quick, brief, final look at a last feature of glacial deposition, which is an erratic, and then we're going to look in detail at a couple of features of meltwater deposition. Okay, so meltwater deposition, guys, is when basically the glacier melts, and it's the stuff that the meltwater drops or deposits can form things. Okay, so first of all, we're going to have a quick look at our final feature of glacial deposition, which is our erratic. And our erratic, guys, is literally just a large boulder or rock. Okay, and it's a large boulder or rock that should not be there. Like if you look here, okay, we've got this, that's an erratic there. Kind of looks a bit out of place. This one here, that's an erratic, that's a bit out of place as well, okay. Now, how did that get there? Well, that got there by glacial transportation. So the glacier basically picked up that large boulder and brought it from one area, and then it was dropped or deposited in another area, okay. And again, an erratic can tell us how far a glacier has travelled. So, for example, granite erratics from Northern Ireland can be found in the limestone region of the Burren County Clare. So, a glacier would have picked up bits of granite in Northern Ireland, and as the glacier moved, it eventually dropped or deposited those bits of granite in the Burren County Clare. Okay, so it's just, an erratic is a rock that's out of place, that's been picked up in one area and basically dropped somewhere where it shouldn't be. Okay, very, very straightforward, and that's our final feature of glacial deposition. So guys, we're now going to move on to, we have got two features of meltwater deposition, and we're going to look at the one in front of us in detail, and then we're going to have a quick brief look at the next one then, okay? And the one in front of us is called an esker. Okay, an esker, guys, if you look at the yellow box here, comes from the Irish word Esker, which means a ridge. And that's exactly what an esker is. It's a long, narrow, kind of winding ridge. Okay, and the ridge is made up of bits of sand, gravel, and dirt and mud. Okay, and that ridge was deposited there by melting ice off the glacier. Okay, and guys, an esker can be quite big. An esker can be about 30 meters in height. Okay, so they're not small. All right, so now, how does an esker form? Very, very straightforward. So, esker started to form, guys, when the ice age in Ireland began to end. Okay, so when the weather started to get hotter, the summer started to get warmer, and the ice started to melt. The glaciers started to melt pretty quickly. Okay, now when glaciers melt, and a glacier melts in an unusual way. When a glacier melts, the ice actually forms a little bit of a tunnel underneath the glacier. Okay, so you could technically walk into that tunnel under the ice. It's just the way glaciers melt. Okay, so they kind of melt from the bottom first, and as a result, a little tunnel forms. Now, what happens when in this tunnel? So as the glacier retreats back, this tunnel becomes full and choked with sediment. Okay, so as the water that melts, okay, or the ice that melts, the meltwater off that ice carries bits of sediment, and this sediment fills up and takes up the entire tunnel. Okay, and the tunnel kind of organizes the sediment into a little neat ridge. Okay, so the sediment gets deposited or dropped. Okay, and it gets deposited in this kind of way in a ridge. Okay, and again, why is it deposited in a ridge? It's deposited in a ridge because of the tunnel in our glacier. The tunnel in the glacier kind of naturally deposited in a ridge. Okay, sediment is then deposited again, as you know. The larger, heavier particles of sediment get dropped first, followed by the smaller ones. Okay. Final point. So in the summer, there's more deposition as there's more melting. Okay, so there's no surprise there. The hotter, wet weather in the summer means the glacier will melt faster. Okay, and as it melts faster, it leaves behind a long, narrow, winding ridge of sediment. What's this called? An esker. Okay, very, very, very straightforward, guys. Really, really simple. So we've got our glacier. It's melting. As a glacier melts, and it kind of melts from the bottom first, leaving a tunnel. And as the glacier retreats backwards, this tunnel kind of naturally sorts out the sediment and forms it into a little esker here. Okay, very, very straightforward. All right, and that's the one, guys. I want us to do our deep D answer: define, explanation, example, processes, and diagram. I want us to do that today for our work. Okay, so final feature of meltwater deposition, we're just going to look at really quickly, guys, is an outwash plain. Okay, and an outwash plain is a flat area of gravel and sand found in lowland areas. Okay, so an outwash plain is really, really simple. When ice melts, okay, what does the water do? The ice do? It melts and turns into water, and that water just flows away from the glacier. And as it flows, it just drops sand and gravel and rock. Okay, and what happens? It spreads out and it kind of makes a big flat area called an outwash plain, a big flat area of sand and gravel. Okay, outwash plains are actually infertile, and they're not good for farming, so they're often used for grazing. So all you can do here is basically graze. An example is the Curragh in County Kildare. Okay, so the Curragh, we've got the racetrack and the army camp, is an example of an outwash plain. Okay, you can't really farm there, except you can just keep a few cattle on it. Okay, thanks for watching, folks. Again, to recap, guys, an esker is the one we must know in detail. An esker, how's an esker formed? Retreating ice glacier. As the ice melts, it melts from the bottom up, leaving behind a little tunnel. Okay, and as the ice melts, what happens? Any bits of sediment and stuff that are carried in the glacier get dropped, and then they get sorted out by the shape of the tunnel. Okay, as the ice retreats back, so the ice used to be here, it's now retreated back, leaving behind a ridge of sediment. Okay, forming behind our esker.